problem based on equal functions. So here we are going to perform problems which are based upon the equal functions under the advanced level. Here when we assume two functions as f and as well as g, then those two functions are said to be equal, that is f equals to g, or in other words f of x equals to g of x, unless and until f of x is equals to g of x. So here f and g won't be equal. If f of x is equals to g of x, then we can write it as f is equals to g, that is the function f and g must be defined on the same domain, which is denoted by means of d, that is capital D. So here the first example, so under this example, let function f is from except 3 the reals, that is the domain of the function f, into the real numbers, be defined by the function f of x is equals to x square minus 16 overall divided by x minus 4, and the another function, that is g, which is from reals into the real numbers. So it is defined by the function that is g of x is equals to x plus 4. Then show that these two functions f and g as equal. So we have to prove f is equals to g. So in order to show f is equals to g, so here the proof starts now. So in our proof, so here as per the problem which is given to us, function f is from R, the real except 3, to the real defined by the function that is f of x is equals to x square minus 16 overall divided by x minus 4. Then now here the domain of this function f set consists except the 3. So here all the remaining real numbers. So here let us find, first of all let us write the domain of f, that is the first function, is equals to set consisting except 3. So here we can write it as 2, 4, 5 and so on. Then now similarly the next function is given by means of g from real to real defined by means of g of x equals to x plus 4. Then whereas in the next logical step, second function that is g is from real numbers to the real numbers, the domains are of real numbers defined by g of x is equals to x plus 4 as per the problem which is given to us. Then now here we can find out the domain of this function that is g. So here domain of g is given by means of the reals, so we can write it as 1, 2, 3 and so on. But here since the equal functions depend upon the domains, that is the same domain, but we know that two functions, say f is the first function and as well as g is the second function, are defined on same domain, then functions f and g are equal functions if and only if the condition is of, so if and only if f of x must be equals to g of x. So based upon this condition, so here the two functions will be equal, that is f of x equals to g of x, that is the functions must be defined on the same domain. So here let us take the same domain I say here in the first, say in case of f function, that is r real numbers except 3 to r, so defined by means of f of x is equals to x square minus 16 overall divided by x minus 4. So here we got the domain of f is equals to two, 4, 5 and so on. So here 2, 4, 5 and so on, and at the same time say here next domain, so here next function is of g, so here real to real, so here defined by means of g of x is equals to x plus 4. So in this case the domain of function g is given by means of 1 to 3 and so on. So 1 comma 2 comma 3 and so on. So here since it is depending upon, so here the equal functions depends upon the same domain. So let us assume the same domain as 2 in the function f and 2 in the function g. So here we have assumed the same domain as 2 in both the cases, that is both the functions f and as well as g. Then now the next logical step will be of, we have to, in case if we prove f of x is equals to g of x, then by the at the same domain, that is 2, then the functions f and g are said to be equal. So now the next logical step will be of so here f of x is given by means of x square minus 16 overall divided by x minus 4. So here at x is equals to 2 at the same domain, that is x equals to 2 in the first one, that is the case number 1. So we are going to write it as the case number 1. So here that implies f of x replaced by means of this 2 is equals to, so x square, so here x value is of 2, that is 2 square minus 16 written as it is overall divided by x value is of 2 minus 4. So here that implies the next logical step will be of 2 square value 2 repeatedly multiplied 2 times 2 2's is of 4 minus 16 written as it is overall divided by, so here 2 is of positive and 4 is of negative, plus of minus is minus. So we have to subtract greater minus this, that is 4 minus 2 is of 2. So 4 is greater, its sign is of negatives, therefore 2s is the sign of negative. So whereas in the numerator, so here let us simplify, 4 is of positive, plus of minus is minus, then we have to subtract greater minus this, that is 16 minus 4 is of 12, 16 s is the sign of negative, therefore 12s is the sign of negative. So here minus 2 as it is. Then now further simplification, 2 in the denominator 2 ones and 2 in the 2 6 times in the numerator. So here minus minus gets cancels. Therefore 6 by 1 is of 6. So in this manner I got, therefore f of 2 is equals to 6 as in the first case. Then now we are going for the second case, that is case number 2. So in our case number 2, the second function is of g of x. The g of x is given by means of x plus 4. So here at same domain, that is x equals to 2. So here the domains are same. So here it is of the domain x equals to 2 and the domain is of 2. The domains are same in both the cases on same domain, on same domain. So that implies, so here g of, so x must be replaced by means of 2. So that implies when x is replaced by means of 2, so a plus 4 written as it is, so that implies 2 plus 4 is of 6. So in this manner I got, therefore g of 2 is also of 6. Then now let us assume this as the first equation, f of 2 equals to 6 as the first equation, then g of 2 as the second equation. Then from 1 and 2 equations, that is the first one is of f of 2 equals to 6, the first equation, and g of 2 is equals to 6, the second equation. It is clear that the right hand sides are equal, therefore the left hand sides must be equated. So here we can write f of 2 is equals to g of 2, or in other words it can be expressed as f of x is equals to g of x. Then certainly we can write it as functions f and g are equal. So here hence functions f and as well as g are equal functions. Hence it is proved.